Okay, I'm getting chats so people can hear me. That's fantastic. I'm happy to hear that. It's the first time I'm using AnyMeet, so always a bit nervous about technology these days. But luckily, we've all been used to working in all sorts of platforms from home for the past few months, so we're getting more comfortable with that. Well, first of all, thank you all for joining. I appreciate everybody making the time on this Thursday afternoon to join, assuming it's afternoon wherever you are. Second of all, just to quickly introduce myself, my name is Oana and I'm in the data science team at Nielsen. I've been at Nielsen for a little over 8 years, and I'm based in New York. And today I'm going to be talking about Agile. But first of all, a bit of a disclaimer. If you have worked in an Agile framework for a long time and you're a data scientist and you've been doing this for ever and you can do it in your sleep, you might want to drop because this presentation is not for you. It's for those of us who are a little bit newer to Agile and who are still learning on a fairly steep learning curve and who are just starting to wrap our brains around what Agile means and how we can make data science more Agile and how we can make Agile work for data science. So with that in mind, I'll be specifically focusing on the Agile mindset and more on that in a minute. So in terms of what I'm going to be talking about today, hopefully everybody can see the agenda slide. Yes, people can see the agenda slide. I have a different view than others, but that's the slide that I'm on right now. What I'm going to be talking about is, first of all, introducing the concept of Agile, introducing, again, for those of you who might not have worked in Agile for a long time, or for those of us who are still learning about it. Then talking about the Agile mindset and what it means for data science. And I've kind of distilled it to 3 components: committing, identifying, and planning. And I'll explain what those are when we get to that slide. And then I'll provide an example so it's not all theoretical and abstract. And then talk about a little bit of our personal experience, what worked for us, what didn't work for us, what we've learned in the process of becoming an Agile team. So first of all, Agile. It's a buzzword. We've all heard it. I Googled it, and I just took a screenshot of a definition of Agile from a pretty reputable website. I'm sure everybody is sort of Atlassian. That's where the definition is coming from. There's a lot in there. I'll let you read it on your own if you'd like. I'm not going to read it verbatim. There are many words. And some of those words, for those of us who might not have seen this definition before, might seem a little bit confusing. So Agile talks about things being iterative. Well, isn't everything in data science iterative? Don't we always try things and improve things and try again until it gets better? Why is it special for Agile that it's iterative? It's applied in software development. Really only there? Then why do we talk about Agile for data science? You want to create things of value for the clients. How do you define value? What is that? Is value just the fact that we delivered something? Is it supposed to also be good? How good is it supposed to be? And then we talk about small increments. Sorry, I might have to look at the screen really closely because it's very small. We talk about small increments. How small? Define small. Is it a day? Is it a week? Is it a year? Anything could be small, especially when you do research and development. That takes a long time. And so, how do we understand what this means? There's something in the definition also about mechanisms. What's a mechanism for R&D? How natural does that even come to us when we start building something without knowing what the final product is going to be like? So I'm going to try to get to some of these things in red throughout the presentation. These are things that at first look might seem confusing to somebody who's new to Agile, especially somebody who's working on R&D, which is what my team is doing at the moment. So let's try that again. I have put here a definition of Agile in my own words. I did not take that from anywhere. I literally just sat back and thought about how I would define it to somebody if I were to do it from scratch. And I will read this one because it's a little bit shorter. And so the way that I think of Agile is a work and collaboration style that encompasses the logistics, the mindset, and the tools to work quickly and in small increments toward achieving a predefined goal. For example, building and enhancing a new product for clients. That's how I think of Agile. But let's unpack that even more. Okay, when we talk about logistics, what is that? When I think of logistics, I think of things like how often does the team meet? Do you have daily stand-ups? Do you have stand-ups that are twice a week or 3 times a week? Also think about meeting structure. What are these meetings about? Is every meeting the same? Does every meeting have the same agenda? Is the agenda structure the same? Does everybody need to attend every meeting? How do we actually talk to each other? And this is especially important now with everybody being at home, where you can't just walk to somebody's desk and tap them on the shoulder and be like, hey, I have a question about XYZ issue. You kind of have to plan these things, and you have to have scheduled meetings on everybody's calendars before everybody's calendars get booked up. I also talk about things like when we provide a piece of code, when we build something, how do we know that it's good? How do we share that with the team, and how do we review it as a team to all agree that it's good enough to move forward? The other element that I mentioned was the mindset. What does that include? It includes things like being okay with an MVP, which means in this case, minimum viable product. It's okay to release a product that's an MVP. It's not the best it could be, it'll get better, but it's something that we could do quickly and that we're happy enough with to be able to show it to a client. It also entails things like the belief that perfect is the enemy of the good. Again, as I mentioned earlier, we might not have built the best thing ever that we could have built with our skill set and time, but we built something that was good enough to deliver in the short amount of time that we had allotted for it. It also includes the well-known saying, fail fast. It's better to try something quickly before overthinking it, and if it doesn't work, move on, than to agonize over every decision but not actually do anything. And then in terms of the tools, these are fairly straightforward, I think. You need some way to manage the work. That could be something as plain and simple as an Excel sheet, but there are more advanced tools these days like Jira, which allows you to enter the different tasks and when they're due and what dependencies they have and who's working on them and for how long and all those beautiful things. It also entails having a place to store documentation. If you've written a recommendation for something, if you've developed a methodology, where do you put that so everybody can see it? For that, there are things like Confluence, which is a really good place to put these more elaborate, essay type arguments. And then it also entails having a place, for us data scientists in particular, to put code so that everybody can access it, everybody can look at it in real time and can immediately react if it's good or bad or if something needs to change. And so for that, you can use something like GitLab, which is a collaborative coding platform. But the one thing I want to focus on among all of the things that I mentioned, because I think that's the hardest one to really achieve and implement, is the mindset. How do you achieve the Agile mindset as a data scientist? And again, especially those of us who haven't worked in Agile before, how do we get there? I think, first of all, to understand why we even need to get there, let's first understand why Agile is even good. Why is it a good thing to be Agile as a data science R&D team? Well, first of all, iteration. And you might recall from that slide with all the red squares that there was the word iteration in there, and we were all wondering what that means. Iteration means trying a lot of things really quickly and moving on. And what's good about that is that it fosters speed, and it also fosters flexibility. So if you build a small chunk of something really quickly, and then you like it and you release it, you can move on to the next chunk. If you don't like it, you can quickly redo it and make it better next time. Someone wrote a comment, there's a delay. Yeah, we were told by the organizers that there's about a 10-second delay. Okay, so back to what I was saying. Why is iteration good? It allows you to work faster and more flexibly. So what that ultimately does is it allows you to deliver things to clients more quickly and to more clients. Because if it takes you less time to build each thing, you can build the next thing that much faster and sell it to that many more people, which is good for business. Also, collaboration. I mentioned that Agile is a collaboration framework. Collaboration helps you work fast too. For example, contrasting it with the old way of building something as a team together. Let's say there were a bunch of data scientists in our little, hip place in the office building a product. We think it's great, and then to implement it, you have to send it over to the application development team, let's say. You throw it over the wall to them, and then they take some more time to build it, but they might build it in a way that doesn't align with your expectations. They might run into difficulties implementing the code as you wrote it. And so if you wait until the thing is finished to collaborate why is Agile good for R&D? It's because it prevents things like analysis paralysis. It kind of forces you to make a decision and build something and move on, and not spend years and years agonizing over whether you have the right approach, or the right data set, or the right framework, or the right package for your code. It just kind of forces you to build something and let go. It also helps you get over this mentality that we're not going to share anything until it's perfect. You work with a bunch of data scientists on some really cool deep learning model, but you don't share it because you don't think it's good enough yet. So to other teams, it might look like you're not making any progress. Can you still hear me? Okay. Just checking the chat. Okay, glad that I'm back. Not sure what happened. I was here the whole time. And then, of course, the saying that I kept hearing a lot in my graduate studies, boiling the ocean, splitting hairs, thinking about all the possible ramifications and all the possible features to include and everything that's ultimately going to bring diminishing returns, when you could just release something what you have, the 80-20 rule, and move on without spending any more time thinking about little things that are not going to make that much of a difference. Okay, just checking the chat every now and then to make sure we can hear. Okay, so back to the whole mindset thing. How do you go about adopting an Agile mindset, right? It's not like you can just go to the store and buy it, but sometimes it actually kind of is. Oftentimes what happens is the data science team might be told that the organization or the broader cross-functional project team is going Agile. So it's not like you have a decision to make or a choice. You're just kind of informed. Okay, we're all Agile now. We're in a Scrum team. Get on board with it. Then the other thing that might happen is the organization decides to adopt a specific tool. Like everybody needs to work in Jira now. So that's what you're going to have to do. So again, back to the three elements that I mentioned earlier in terms of embracing the Agile mindset. There's committing, there's identifying all the different work streams, the motivation for it, why you're even working on this, the outcome, what do you want to achieve, and the process, how will you do it? And then once you've accomplished all of these and you can agree the task is done, using a definition of done, you move on. And then lastly, there's the planning component where you have to know how long each task will take, for how long you will work on it, and then by when do you want to be done with this particular chunk of work. And I'll talk about each of these in turn. I already kind of mentioned some of this. For the committing part, this is fairly straightforward. Sometimes you're just told that you have to do it. You might be confused about it. You might ask, what's all this jargon? What is Jira? I've never used it. I don't understand, why I have to do it all of a sudden. And why do I need to have a stand up every day with all these different teams and explain to them how I'm building my random forest model? But ultimately, the best way to learn this, I think, is by doing. You can have really nice deck, kind of like how we have here, with graphs and images and everything. But until you get your hands dirty, so to speak, and until you actually work yourself in Jira, writing tasks, attending the stand-up, it doesn't really click. So ultimately, if you're informed that your team is going Agile, just embrace it and start doing it, and it'll click in time just by doing it. In terms of identifying, the old question from the office, what would you say that you do here? As data scientists, often when we do R&D, we tend to give the update that still working on the model, I'm still researching different ways to predict XYZ metric. That's not really helpful, right? When you say you're still working on the model, you are doing something every day, something every week, something even every hour. You need to articulate what that is. And I found that a good sort of typology for the different work that we do in data science is categorizing tasks into three different types: information, code, and model. And then it becomes much easier to see what the how, the why, and the definition of done are if you think of tasks in these three different ways. So let's take them one by one, and I will give examples, so don't worry that it's very theoretical still. Information. What's an information task? It's basically arriving at an answer that helps you make a decision. It involves obviously answering the question. That's how you know that you've achieved the task. And the way that you do it is you collect insights. You could Google it, you could read some of the literature, you could talk to subject matter experts, talk to colleagues, ask around, get the information that you can then put together to make a recommendation and a decision and move on. So the definition of done for this is, obviously you've answered the question. The answer is documented, right? So it's not all in your head. It's put somewhere where everybody else can see it. The documentation includes everything that a person would need to know to arrive at a similar answer themselves or different. But that's not the point. The point is you have your sources, you have your data, you have notes from all the meetings you've had to get the information that anybody can access later on if the team changes or if the product gets put on hold for months. Somebody can go back and look up what you've done and arrive at the same or different answer, but the point is they have all the data there to make a decision. That's information. Code. This is kind of the bread and butter of data science. It's fairly straightforward. Here you write a script to produce some kind of a metric. That metric could be the end goal of the product, or it could be an input to some other metric. But the point is you've written a way to calculate that metric. The way you do it, I mentioned earlier, ideally in a shared location using a shared repo that everybody can see, everybody can review. Git is good for that. But the point is you have to discuss it with others, and other data scientists have to see it. It's not sitting in a notebook or on your desktop or in a text file that nobody else has. And you know that it's done when others who have seen the code think that it's good enough and accept your merge request in the case of Git. So the team agrees that that portion is done. And then model, that's basically putting all the pieces together. So you have a bunch of chunks of code, one that computes metric 1, another one that computes metric 2, another one that computes metric 3, but the product has all of these metrics combined into something. So the model essentially sets the configuration and hits run so that all of these components can be grouped together and produce the final outcome that you want to deliver for your product. The reason why this is important, obviously there's no product without it, right? The whole point of building a model is you arrive at some kind of an insight that a client wants. The way that you do it, again, has to be very structured and shareable. Something like MLflow is good for that. And it's done when the code module exists in a shared location and can be reproduced anytime the product is needed. So you don't have to reinvent the wheel, essentially. For planning, that's the structure. I'm going to skip this. It talks about epics, tasks, and subtasks. It's pretty straightforward. I'm not going to dwell too much on this. But the point is that a hierarchy of the work, which tasks fit under which stories and fit under which epics, helps you plan the work both in terms of time and in terms of resources. Epics are kind of like books, like volume 1 of the trilogy of Lord of the Rings. Stories are chapters and tasks are pages. And of course, it gets more and more specific, but also the broader team, the cross-functional team, doesn't need to know the weeds of tasks, but they do need to understand why a task contributes to building an epic. And then in terms of planning, estimation usually happens in terms of development cycles or sprints. Ideal length is 2 to 3 weeks. And you can estimate epics in terms of story points. People use Fibonacci sequence, but you don't have to. Stories in terms of hours, and tasks ideally should last a few days, definitely less than a sprint. And then I have some examples here. I will go through this very quickly. For example, a task to understand what the best way to detect outliers is an information gathering task. A task might take you 40 hours. And the way you do it is you look it up on Google. To implement that, that is a code task. It might take you 20 hours. And the way that you do that is you do it in Python. And now just to wrap it up, I'm going to talk about a few things that worked and didn't work for us as we were becoming Agile. And I kind of put it there as thou shalt and thou shalt not. It helps to ask a lot of questions, even philosophical ones. Why are we doing this? Why do we have to become Agile? It does not help to make assumptions because that can lead to misalignments in how long things take and who does what and why it matters. It helps to just have a doer mentality, do first and think later. If you're in doubt about the methodology, implement it, see what happens, and then if it doesn't work, move on, versus being paralyzed by the fear of it not working. Sharing always works in terms of bouncing ideas, sharing code, sharing documentation so that there's visibility and the team can quickly act if something doesn't quite work or align. And then lastly, openness and flexibility, including in terms of how Agile is applied. Sprints don't have to have a standard length. Do what works for you. Stand-ups don't have to have a certain cadence. Do what works for you. So I would like to thank everybody with that. And, I'll stick around for questions for a few minutes. If you have any questions, you can also email me at my email address, which is right here. And I also wanted to acknowledge colleagues that have worked with me on this, which I did in the previous slide. So thank you, everybody. I'll let you all go to different sessions if you have them, and I'll go to the breakout room for a little bit in case there are questions in there.